Welcome back to beginner lessons in our programming. In our previous lesson, we learned how to create vectors and we went ahead to use these vectors for some basic political analysis. Today, we want to proceed from there and do something even bigger with vectors. We're talking about indexing vectors. Indexing here means that we want to be able to slice some part of our data. We want to be able to pick some portions of our data, do some manipulations with it. We want to have control of our data. If the data grows bigger, it's sometimes difficult to have a view of the data all at once. We want to be able to select some part of it and do some basic calculations or do some comparison or append some new information to the data and so on and so forth. And that is what indexing vectors is all about. In today's lesson, we want to look at a different example other than our previous example. In our previous example, which I have right up here, we were interested in US citizens that are affiliated to a particular political party or the other. In this particular lesson, we are interested in political party campaign expenditures here in the United States for a certain week, Monday to Friday. We got the data for how much each political party, the Democrats and the Republicans, spent each day on their political campaigns, and this amount is in thousands of US dollars. So let's go ahead and then create a vector that shows this information that we have for these two political parties. All right, so we have here data on Democrats and the Republicans for Monday to Friday, how much they spent on the political campaign. So $120,000, $80,000, and so on and so forth. And then these are coded into a Democrats vector and a Republicans vector, just as we learned in our previous lesson. Now, we want to also show that this data was collected from Monday to Friday, right? Because we didn't do for Saturday, we didn't do for Sunday. So we want to be able to specify that. And we can do that in a string vector like this one here. So we have the days that the data was collected, and then we have the expenditure for each of them. Now, what if we wanted to link them, right? Even though we have a string vector from Monday to Friday, and then we have a Democrats vector, Republicans vector for the figures that they spent each day, but we want to be able to call the Democrats vector and then have the day that the data was collected coming with the figures all together. How are we going to go about that? I introduced to you a new function called the names function. You could always come to the right section of the interface, somewhere here, right? And then type in the function that you want to learn about. And R gives you tutorials on how to use that particular function. So it is a very, very helpful way to get to work with these functions even if you forget how they work, right? So check them out later on. Now, what we're going to pass to the names function is these integer vectors that we have here, the Democrats vector and the Republicans vector. And then we are going to assign to it the days of the week so that the data would be joined together. So we're not going to have a separate Democrats vector and days vector. We're going to be merging the figures with the days of the week, and that is what this names vector is going to do for us right now. The names function works quite differently from other functions. The name function is going to behave like an object in itself that you are passing some other data to it, right? So you can have the names function, and we are interested in linking some days of the week to the Democrats vector. So the Democrats vector that we want to make changes to, right? So we're going to have it as an object. We're going to make the whole function and the argument that we've passed to it behave like an object. And then we're going to pass to this object the days vector. Now the days vector is essentially the days of the week that we have. So we're going to pass the days of the week, this function that is behaving like an object for once, right? And then make sure that we are linking it with this sign here to make it one data. All right. Now, if we run this and then we called Democrats vector again, now we have the days of the week assigned with the expenditure that was collected for each day. That is amazing, right? So now we don't have separate vectors. We have one vector for the Democrat, and then it shows everything that we need to know. We can repeat the same thing for the Republicans as well, and have the Republicans also showing the days of the week that they spent that amount on their campaign as well. We can equally do the same assignment to the Republicans vector that we have here as well, right? So we are linking the days of the week to the Democrats vector, and then we are linking the days of the week to the Republicans vector as well. Now let's see how much our data has changed since we assigned the days of the week to it the using the names function. Let's run everything and see what we have. As you can see here, the days of the week have been linked to each day that the political party spent this amount or the other during their political party campaigns within a certain week. And we're going to go ahead and work with indexing now that we've been able to link each day to the amount that they spent on their campaigns. So before we get to indexing, let's look at how much the Democrats spent on their campaign for each particular week and how much the Republicans also spent on their campaign for that particular week, right? Now, if you remember from the previous lesson, we learned the sum function. So we can use the sum function to calculate how much these political parties spent on their campaigns and call the object that we use to save that information and see what we have. Okay, so the Democrats spent $650,000 in that particular week, and then the Republicans spent $500,000 for that particular week, right? Now, if you're not familiar with how the sum function works, please check out the previous lesson before this one. We spoke about the sum function and other functions that are really, really great for basic social analysis. Now, it can even get more fun if we do a comparison between the Democrats and the Republicans, which party spent more on their campaign than the other. And then we can do that with a new object called the spend more and do a comparison, right? Using the comparison sign that we have here, the greater than sign. This is just saying that the Democrats spent more than the Republicans, and R is going to return to us the logical value of true or false, depending on whether the case is true. Let's check it out. If we run this information, we get true. It means that it is true that the Democrats spent more on their campaign more than the Republicans. Let me introduce you to a new function called the cat function. And the reason why we're talking about the cat function is that it works like the print function in Python. We are able to assign some arguments to this function, and what R does is it prints that information for us. So we can put a couple of things in there, and then it comes out as one information printed all together. And I'm going to take you through an example of how this function works. If you look at this particular line of code here, what we are basically telling R to do is use the cat function to print out a normal text, right? Because this is a string of character data. So print out a normal text that says total expenditure for Republicans and add the dollar sign to it. Now, another argument to this function is print out the value for total Democrats. So total Democrats is here. Whatever we got for total Democrats, print it out. What the backslash and n here tells R to do is it tells R that as we add more cat functions, don't print out line 78 to line 80 on the same line. We want line 78 to line 80 to be printed on separate lines. So that is basically what the backslash and n here means. If we run this line of code, what we get is that R prints out the words that we put in inverted commas, it prints out the dollar sign, and it prints out the values embedded in the objects that we assigned to the cat function. Here it prints out true because inside the spend more object, it's a comparison between how much the Democrats spent and how much the Republicans spent. So it's a comparison between these two. Now let's get into the details of what indexing is about. In indexing, what R uses to slice data for you is the squared bracket. Now, what a squared bracket does is that it slices some part of the data that you want and uses it in the way that you want to use it. If you consider this line of code that we have here on line 85, we are telling R that inside the Democrats vector, slice only the data for Wednesday, slice only the expenditure or how much the Democrats spent on their political party campaign on Wednesday, and assign it to a new object called expenditure Wednesday Democrats. And that is what indexing is about. Now, if we called the expenditure Wednesday Democrats object, R tells us that the Democrats spent $100 on their political campaign. So we've been able to index some part of the code data that we had and use it in some way to benefit our analysis. What if we are interested in finding how much the Republicans spent on Tuesday, Wednesday, and Thursday? We could use this line of code here, right, to find that information. What this line of code tells R is that use the combine function to combine Tuesday, Wednesday, and Thursday inside the squared bracket and take it out from the Republicans vector. Now, the Republicans vector has information for Monday to Friday, and we want only these 3 days. If we run this line of code for the Republicans midweek, what we find is exactly the information that we want for only the 3 days that we are interested in, as you can see below here, right? That is amazing. That is what indexing is about, to be able to pick some form of data from everything else and use it for analysis. We could do more things. We could do some sort of conditional indexing. Now, what conditional indexing means, that conditional is asking R or asking a particular data software to do something based on a certain condition. So print for me this information depending on if something is true or false. And that is what conditional indexing is about. Assuming you were working for the Democrats, and the Democrats did not want to spend more than $130,000 for a particular month, and they ask you, can you help us find which of the days we spent more than $130 on our campaign? Then you could use the same skills that you've just acquired in indexing in addition to a greater than sign and 130. Now, what this tells R is that we want to find out any value of the Democrats vector that is greater than 130. If we run this line of code, what we will get is any amount that is more than $130,000. Okay, so we can see that on Thursday and Friday, the Democrats spent more than they were supposed to spend. They spent more than $130. Now, if we want to know exactly how much they spent, we could use a similar code like line 89 to find out exactly how much they spent on Thursday and Friday. And this is good skills to have when you're doing this sort of analysis and you want to be able to dissect into your data and then bring out more insight. Now, we can also use these same skills that we've acquired in indexing to modify our data. Let's roll up a little bit. Whilst coding this data on line 54, assuming you made a mistake, instead of $140,000, you wrote $120. Now you can use indexing to correct this, right? So what we're gonna do is we can slice out the information for Monday and ask R to assign a new value to Monday. Remember, in our very first lesson, we said that we can override every information in a particular object. So we are now overriding only the information for Monday because we use the squared bracket to slice out the data for Democrats on Monday, and we are changing the value to 140. We realize we made a mistake and we want to change it to a different value, and we can use indexing to do that. Now, if we run the Democrats vector one more time, we can see that that correction has been made. So now the value for Monday is 140 and not 120. These are amazing things that you can do with just these skills in indexing. This is what we call data manipulation. One more thing about indexing is that we can index with numbers instead of using names. We can index with the position of our data in the data set instead of using Monday to Friday. So if you look in the console, you see that the data is arranged in a certain order. Monday is 1, Tuesday is 2, 3, 4, 5. Like they are in first position, second position, third position. Assuming we are interested in how much the Republicans spent on Wednesday, we can slice that data with the number 3 instead of using Wednesday, because we know that the data for Wednesday is in the third position in the Republicans vector. Using 3 in our curly bracket will give us the same result as using Wednesday. If you check it out, it gives you the information for Wednesday, which is 90, and it's sort of the same results that we had when we used Wednesday for the Democrats online 85. So you can use numbers for indexing as well. In this last bit, we can use the cut function to print out everything that we've done and bring out just the results. Now, if I run everything here, I'm going to get the results for everything that we've done so far. In these white lines beneath, it gives us exactly the same information we got whilst we run everything one by one, one by one. So we end our lesson on indexing vectors here. If you liked the analysis, please like and subscribe. You can also leave a comment below and let me know what content you're interested in learning in R, as well as what I could do better in terms of helping you on your journey to R programming. See you soon in the next lesson. Bye.